Electric Circuits Question 2. Part A. Calculate the resistance of a piece of aluminium foil 1 meter long, 2 centimeters wide and 0.1 millimeter thick, and we're given that the resistivity of aluminium is 2.7 times 10 to the minus 8 ohm meters. Well, for this we need the equation R equals rho L over A, which is given on the data sheet. R is the resistance in ohms, which we want to find, rho the resistivity in ohm meters, which we're given, L the length we're given, and A the cross-sectional area we can work out from multiplying the width by the thickness. So, if we put the numbers in and calculate out, we get a resistance of 0.0135 ohms, which I've rounded to 1.4 times 10 to the minus 2 ohms. Part B. If the strip is now folded in half lengthways, what will be the new resistance between the ends 0.5 meters apart? Well, for this we could do a new calculation using the new dimensions, or we could realize that the length has been halved, which will halve resistance. Also, the area has been doubled, which will have the effect of halving resistance. So, the overall effect will be that the second resistance will be half due to the halving length, multiplied by half due to the doubling area, multiplied by our original resistance, resistance 1. So, this will be a quarter of the original resistance, which is a quarter of 0.0135. I've used my fully calculated value here rather than the rounded value, giving a new resistance of 3.4 times 10 to the minus 3 ohms, or 3.4 milliohms. Part C. You are now given a strip of similar dimensions to the original aluminium foil, but of a different material. Describe how you would carry out an experiment to determine the resistivity of the material. Well, first we could draw a circuit diagram, and we need a power supply, an ammeter to measure the current through the foil, and a voltmeter to measure the potential difference across the foil. Then we would need to measure the dimensions of the strip in several places and take an average. We would need to know the current and the potential difference through and across the strip for several lengths. Then, using Ohm's law, resistance is equal to potential difference over current, we can calculate the resistance for these different lengths. From the equation R is equal to rho L over A that we used earlier, we can link this to the equation of the straight line through the origin, y equals mx, where R can be our y value, rho resistivity can be our gradient m, and L over A can be our x value. Then we can plot a graph of resistance against length over area, and we should get something like this: resistance on the y-axis, length over area on the x-axis. And we should get a straight line through the origin, and the gradient will give us the resistivity. You could do this by cutting the strip, or simply having the connections closer to each other.